Hi everyone. My name is Manoj. I'll start with a little bit of story. This will be just like a flow, very chill, not a very planned thing also. So I'll start with who am I? I'm not a machine, but we all know Linux command. Who am I? It will just stay name. I'll have a little bit more. I'll tell the story because I'm not a machine. So myself, I'll tell a little bit about my personal lifestyle because it's kind of related to the type of open source projects that I take look into. So about my lifestyle, I'm a little bit of like a nomad. I lives everywhere. For all of you, like I'm not based in Bangalore actually. Always, I'm from Malaysia. But something very unique happened, or I feel I'm meant to be here for some reason. Zephyr also, like I actually started first Zephyr event last year. Actually, we had a very less turn up at the time because I was traveling, and we just have so happened to just try it. And from that, I came here again this year without knowing anything that this event gonna happen. And suddenly Susan was like, "Hey, there's this event coming out. Do you wanna talk? Do you wanna give a talk or something?" And so happened that I'm here. Like I was without my laptop and stuff. And I thought like, shit, like I think I'm meant to do this. So I'll just quickly pull up some slides and give a presentation. So myself, my background is I'm a hardware tinkerer, meaning I tinker with hardware, a little bit different from an engineer. Because why I say tinkerer is I'm particularly interested in embedded system because I want to know how embedded system works, meaning on the CPU level, RAM level, and stuff. So one of the way you can't be keep doing it, like you need to fund yourself to do things. So I was developing real projects at the same time learning on the kernel or deeper into hardware level. So that's what I mean by hardware thinker. And professionally, currently what I do is I do PCB assembly. I do full turnkey. We have a small team back in Malaysia. We live in a very nice small island. We are doing all this work. Like to give you some idea, the island is very small, like very small. We from my house like 1 km away, I have like AMD, Intel, Western Digital, all sorts of company just literally staying there. Yeah. And my Zephyr experience is I contributed to the area like new boards, new SoC drivers and stuff. Like I have like 100 commits to date. So let me start with the story how everything started. COVID was there. I left my kind of like a contract job at the time. I was just too free to be honest. And I at that time I was very I said I'm a hardware thinker and I was very comfortable doing hardware designs. Like the type of designs I do is like DDR3 high speed design boards like 8 to 16 layer, and I know how to bring up boards at home. So that was my expertise. So I was offering the service online, and one day a guy, surprisingly, he was an Indian based in I think Switzerland. He told me like, "Hey, you brought up the hardware. You said you know a little bit of firmware. Why don't you develop a Zephyr application for me?" And I was actually arguing with him why you need Zephyr. Like there's other RTOS that I'm already familiar with, and I can really get quick on speed. And he was like, "Oh no, the SOM that I'm using on the product is I think a lot of you might know NRF 9061, I think 9060 or 9061. Sorry about that." He said like that the chip is very complex, like it has a lot of things like NB-IoT, a lot of stuff that you can do, low power and stuff. And Zephyr had a awesome support. Like any of you know, like NRF, the SDK is based on Zephyr. So he kind of convinced me, but I was honest. I was honest to me. I said like I need time to learn. And then I went to Google. I checked. It was like a Linux kernel. From a very long time, I wanted to get into Linux kernel, but somehow the friction was too much. It was just too much. Like you have to think that I'm not working in a company anymore. I don't have a big team. For me to enter, it was so crazy. But when I look at Zephyr RTOS, it was actually quite straightforward. That to jump into the code base was much more easier, I feel. And then at the time I made this thing, I was starting to do more contract jobs. I got elected by some companies to oversee their company's product development. So I convinced an entire team of bunch of 20 engineers, kind of a team, not to use some other RTOS system. I said like, we can use Zephyr. I'm confident about it. Let's do it. And the project went really well. And just to give you an idea, the type of projects I worked on is like a very complex 3D, a three-dimensional control robots with Zephyr. Meaning one controller will be controlling three, motors, X, Y, Z axis. At the same time, it was doing telemetry data to a server. And this was like a warehouse kind of a setup, meaning it's a fully autonomous robot. Like if any communication messed up, collision can happen, crash can happen, mechanical failures can happen. Meaning it has to be very stable and have to be very capable. So yeah, that was my journey. But so jumping into so what's great, what really caught my thing with Zephyr. The first thing was the architecture. So it like the area I worked on, it needs like real time, on probably like nanoseconds sometimes, to do things like a motion. If you're driving motors, you will know you need that kind of precision to really drive a motor. So I choose Zephyr, and why was it has this nice, if you look at that small image I have, it starts from all the bottom. You have a nice hell extraction gives by your vendor, and then you have the kernel that can manipulate with the hull, and then the kernel offer a lot of services. Not only it stops on OS services, because as you know, all RTOS provide OS services like some queuing, some scheduling, and some things. But what the Zephyr had was, it had something more. It has application services and also third-party libraries come into the ecosystem. Meaning like at a lot of my projects, I use a utility or so-called other library like a protobuf. Like in your Python, you can just do pip install. There was no such thing in embedded system world, I felt. So for protobuf, I have to integrate my code myself. That's a very time consuming and bug prone. So I needed something very stable. And that the architecture really convinced me. Now comes the real practical question. Can it runs on multiple board or SoC? Because that's what your customer wants. That's their first question will be. Then again, coming to answering that question, yes, Zephyr runs on all the most architecture like ARM, RISC-V and x86. Even x86, actually it can run on your computer also if you build it with a POSIX abstraction. So, and then for some reason, Zephyr, because it was coming later in stage open source project, it was very highly connected. From the day it has like very good Wi-Fi, Bluetooth kind of connectivity, IDR and network stack inbuilt. Like just say I want to build a TCP application, it was just out of box, things just work right away. And it has also a lot of developer friendly tools that can help with our development. So just to conclude this slide, what I mean is to do a development, we need a lot of other tools. We usually do what is, we go pick ourselves and we put things together, which is kind of, it's possible, but when you scale, when you have team, it's not a good idea, or it becomes very tedious for people like me. I work with multiple companies. So Zephyr had an ecosystem that whatever I needed, it was just there, or if it's not there, it is injectable in a way. I can just inject what I need in a nice way, not a hackable way. So this is what I mean. So what is so great? Documentation, if you go to docs.zephyr.project, currently you have a very good guide from installation, from the API, sometimes even architecture design. Like earlier, one member was asking about worker queue and stuff. Like when you go and read about worker queue, sometimes they also give you use cases. Like how can you use it correctly? Like I remember like 2 years ago, I took a ISR example. I just wanted my ISR. They clearly said that if possible, don't do anything in your ISR. You would use some strategy like worker queue. So for newcomer, it is kind of teaching you the best practice. without even like on your own, so you need good software design pattern and so forth. But for newcomer it's not possible, so if the project itself enforce some good design pattern, for newcomer we can just pick it up. So I feel my software development patterns and stuff just accelerated because there was some good pattern already established. So the another point is, I was as always I was just curious about electronics. I focused on embedded system only, but at the same time I was looking at my friends. They were doing application development. It felt so cool. They said like, hey, I have a Ruby and Rails framework. I have all kind of frameworks to do everything. Like things just work out of box. I just click enter, things work. But for embedded system, for some reason, just moving from one boat, like I used to consult companies to make products chips, like chips become when they obsolete, the product cost goes so high. Just porting a product becomes very costly and very tedious and very buggy way. But this project kind of made it possible. I just have to say Wes bill, I give -b for what kind of board I'm using. So I'm using Raspberry Pi means I give Raspberry Pi. If I give ESP32 means it will bill for ESP32, keeping the application logic intact, because there from day one there's a, like in Linux kernel you have user space and kernel space. This kind of idea was already implemented in a nice abstracted way, and you have all the modules to do. So when I, just to give you some context, when I was coding in bare metal or in some other RTOS, even open source RTOS, because it was too flexible or freestyle in some ways, I can do whatever I want. Like I can just call my normally I have in my main, when we have an MTC main, right, we usually do initialization in just the main. We will directly call the vendor's code on place. Unless you are working for very big company, they have their own way to abstract everything, which is not possible for small team. Which Zephyr from day one said, like, if you want to do any hardware manipulation, if possible, if you already have a hardware API, use the Zephyr's API. That's why it is flexible. When you move board also, application code still intact, it works. Just like your other application, like you have like Java application, you develop, it just runs anywhere. That kind of a concept is possible with hardware. And previously I was talking about a lot of modules, like in embedded system today, you take a look at a simple thing like watch, although it looks so simple sometimes, but it's very complex. You need to drive the display, you need to talk to Wi-Fi, you need to talk to the flash. All this at some point needs another framework into frameworks. Like just say you want to drive a watch with nice display, you want to show some cool look, you need some GUI capable driving framework. For example, Little VGL. So typically what happens before is you need to go download the Little VGL source code yourself. They will have like 1 to 2 3 pages code how to integrate. You will try to integrate. Some people just stops there, like they can't move already because it's already complicated just to set up things. It won't work at times. Sometimes the MCU boot, something crashes and things. But in Zephyr, because it's already upstream in the kernel, somebody will always test it, They will make sure everything, whatever already in the tree integrated, it should be always breaking. It's not breaking, I mean always working. So yeah, sorry about that. And also network connectivity. Like today, all projects that we work simply offline, it's almost impossible. Like all products have some kind of connectivity, which Zephyr already had. And last point is one of the very complicated things I used to handle for people or working experience was device management. When you develop IoT product, automatically you need to give over the air update, which again comes to the point you will normally implement yourself. I remembered 6 years ago we implemented server side guy and embedded guy were just to make a move to do OTA. We were having a big mess up discussion because server guy don't understand something, there were no framework. But today we have something called MCU boot. At least I can tell him, go and look here, this is how it works, and it already worked from start. They already give an example code also. I can convince someone higher on me saying that I can show you a demo. Now the firmware is version 1, I can update to version 2. The first day I get the development bot, if the development bot already support from Zephyr. Okay, so modules is that great, but so just say you have a little VGL module. But modules being there, it's no point. You need to have samples. So the samples are also already given. Actually, I pulled this thing from the documentation itself. So like example, if you want to use there is this called thing can open. Anybody worked on CAN protocol knows there's something called can open library to drive on the CAN bus. So this protocol already been supported. Example code is there how to do bidirectional communication. So you can imagine how easy it is for you to flow. You just take the example working example code, hack the example code for your application. So you speed up the process by a lot, I feel. So now my talk is going to be like, so I was telling about my personal story earlier on 2021, like how, what really caught my eyes. So I just want to open the, or at least show people what opened my eyes. Like I was like mind blown in the embedded world in a MCU space. These are things that already available on Zephyr. So the first thing was Shell. So as you all know, Shell is not a fancy to any Linux guy. But for a 20 megahertz, 100 megahertz MCU, it's not common to have a shell. But in Zephyr, there was this shell utility. You just turn it on. And best thing was the shell had lot of utility, just like a utility command you have in your Linux like ls, mv and all these things. They were already implemented. And what caught my eyes was there were utility like a GPIO. When I need to do prototypes, a lot of time I find I need to recode and flash the board. But today with Shell, I don't have to do that. Just say I buy a flash today. I buy some W250Q flash. I just connect it on the SPI. If the drivers already support, I can take flash, read from some memory. It will dump the information on my shell itself. Isn't that cool? Like normally what you have to do is go integrate, take the example code, go to your main. You do, it wastes a lot of time, I feel. So that is one thing. It's not limited, like all kind of peripheral already supported. Like I pick a picture from documentation. This the code example was, it was setting the gain of the ADC. After you set all the ADC, you can even read the value of ADC, meaning you can even configure peripherals on runtime just by shell. And then the second thing was various transport.
You have time. 8 p.m. 8 p.m. 3 minutes.
Oh, 3 minutes. Okay, cool. I have to be really, really fast. So I'll just go to the real important stuff. So second thing was logging. So in any frameworks, normally in a software development, we have a very cool logging. Things like you want to print message. Normally we will use printf and printk. That is kind of very outdated. We want something new. I'll show you example to speed it up. So when I do something like log error, it will come in rate like this, error message, and then it has a nice timestamp. All this I didn't decode anything. I just put this thing. So you see something called log module register main. That is the module. Module means the source code, the place where the log going to call. So in this case, it is called main. So on the output, you see that after the error is main. So from which source code or which module is trying to create all this information. So it actually accelerate your what you call debugging speed actually. And then last one is tracing. No, actually not last one, tracing. So I'll really quickly pull. I thought I will do a quick. I was trying to be adventurous. I thought I will do all the command live, but we don't have time. So what it does is, at first I will just explain. It builds example code which is tracing. Tracing means you can see post process how your application run on real time. Like if you suspect something like Zephyr is not doing something right, you can do post process analysis. So for this I just built how to say a Linux executable that you can run on your computer itself. And there was an option to create trace file. While it is running, it will create a trace file. And then you can post process that thing from something like this what they call trace analyzer. So anybody that on the commercial world, they will use something like Sager system view. This is also already supported from day one. So meaning I can see on this time frame what are the actual things were running. So you can see, I hope I'm sure I don't think you can read, but these are all the things were running actually. So the next thing I was that really caught my eyes was the device tree or kconfig as a setting, which is already established on the Linux kernel. We normally develop very bare metal guys may only make things work, but it doesn't scale, I feel. So this device tree was really caught my eyes actually, because it gives all the good things, maintainability and scalability. And then this also I thought I will do a demo. I was, I think, very optimistic, but it looks like no. You can do things like unit testing, integration testing. Zephyr had a framework to do testing, which normally it's another big project that will come to question like your team. One guy will say let's use C test, another guy will say let's use this framework. But Z test was just literally working. It can also extend to your application logic level. Oh, cool. So that's my, I mean, a very quick speed presentation. Like I'm open for question now.